All right, this is your third vectors lesson. In this lesson, we're going to learn the scalar product, finding the angle between two vectors, and we're going to learn how to find the vector equation of a line. So basically, those are the objectives listed there. You can find those. Also, add this to your lesson, the assignment at the bottom. That's not on the hard copy. All right. All right, so this might take a little longer, so I'm going to get going and go a little fast. First thing we're going to talk about is the scalar product, also known as the dot product. In vectors, there are two types of products, the scalar product or the dot product, and then there's also another one called the cross product, which we don't learn in SL. It's important to distinguish scalar product, though, from the multiplication by a scalar. Scalar product is a product of two vectors, all right? As you can see, the formula from the formula booklet is given here, all right? And we'll just take a look at how this looks in practice. So I will name this first vector here A, just so we have some names to call them. And the second one here will be vector B. So if I want to find the dot product or the scalar product of vector A and vector B, it's pretty simple. I find it easiest to do them as column vectors. So for vector A, it would be 2, -3, 1. And vector B, it's important to use the dot product symbol, so the dot for multiplication. And then vector B is 1, 1, -1. And when you do the scalar product, the important thing to know is a scalar product will always result in a scalar quantity. All right, your answer is not a vector; it's a scalar. So what you do is you multiply across the rows, all right, and add the products. Okay, so just like that. So this product will turn into 2 times 1 plus -3 times 1 plus 1 times -1. I mean, now we put all these products together, and that would be 2 minus 3 minus 1, and that answer is -2. So the scalar product of A and B is -2. Notice my answer is not a vector. Do not give your answer as a vector when you do the scalar product. Commonly made mistake. All right, now finding the angle between two vectors. There's a couple formulas here. So the first one is in the form of cos theta is equal to, so this one right here, v dot w on top, so the dot product of the two vectors on top, and the product of their magnitudes on the bottom. Notice both vectors in the absolute value bars. And the second formula here is just a rearrangement, okay? And it can also actually be used as another form of finding the dot product of two vectors. So the dot product of v and w is the absolute value of v times the absolute value of w times the cos of the angle in between them. So you could use that if you knew the cosine of the angle between the two vectors, and then obviously knew the two vectors as well. All right. So here's a calculation. So the example says find the angle between vectors A and B, given that A is 3i plus 4j and B is 5i plus 12j. That calculation is going to look as follows. So we're finding the cosine of the angle between the two vectors. All right. So just in vector notation, it's going to be A dotted with B over the magnitude of A times the magnitude of B. So the dot product on top will look like this. It'll be 3, 4, and 5, 12, like that, over the magnitude of each of those, so 3 squared plus 4 squared, the root of that, times the root of 5 squared plus 12 squared. So on top, we have the product 3 times 5 plus 4 times 12. On the bottom, this is root 25 times the root of 169. On top, that's 15 plus 48. That works out to be 63. And on the bottom, it's 5 times 13, which is 65. And obviously, you're going to do the inverse cosine calculation for this. You get a theta value of 14.25 degrees. The three significant figures, let's say 14.3 degrees. All right, so that's how you use the formula to find the angle between two vectors. All right. On the next page here, sometimes you may be given, it might be the corner of a parallelogram. A might be the vertex, one of the corners of a parallelogram. The sides of the parallelogram would be formed then by vector AB and vector AC, for instance. And a question may say, find the angle at A. What's really important here is that if you want to find angle A, or angle BAC if you want, both vectors must originate from the same point. All right, so what I would want is I would want to do the angle calculation using vector AB and vector AC. Okay, so just write that in here. We would want the angle between AC and AB. Okay. If you change either of them around, if you did CA or if you did BA, you would get the, for example, if you did BA, you would get this angle here, the obtuse angle, all right, which is not what's asked for here, all right? Just so you know what you're getting. So sometimes the question may just say, find the acute angle, or it might say, find the obtuse angle, in which case, if you do the calculation wrong, you know that you can use the supplement, all right? Anyway, let's just put some points to these, all right? So we'll call A, we'll say it has coordinate 2, 3. B has coordinate, we'll say 5, 7. And C, for example, might have coordinate 6, 1. And obviously this can be done in 3 dimensions as well. So what we'd first want to do is we'd want to find vectors A, B, and AC, okay? So vector AB, again using our OB minus OA calculation, is going to be 5, 7 minus 3, 2, and that's going to be, minus 2, 3, which is going to be 3, 4, like that. And then vector AC is going to be, again, 6, 1 minus 2, 3, and that would give the vector 4, negative 2. And now again, if we want to find the angle between them, so let's say this angle theta here, all right, we're going to say the cos of theta is going to be the dot product of the two vectors, so 3, 4, and 4, negative 2, over the product of their magnitudes. So the root of 3 squared plus 4 squared times the root of 4 squared plus negative 2 squared is equal to, and so that's 12 minus 8 on top, and on the bottom, again, it's root 25 times the root of 20, so this would end up being 4 over 5 root 20, if you want. Okay, and you can do the inverse sine or inverse cosine calculation with that. When you do that, you would get an angle theta is equal to 79.7 degrees. All right. Anyway, the important thing is finding the angle with two vectors like this. Make sure they originate from the same point. On the next page, parallel and perpendicular vector properties. For perpendicular vectors, okay, using the formulas from the previous page, and using our knowledge of what perpendicular means, the form A dot B is equal to absolute value A times absolute value B times the cos of 90. Well, we know that the cos of 90 is 0, and so that would make the entire right-hand side 0. So the property that's shown here is that the dot product, if two vectors are perpendicular, their dot product will equal 0. All right? So you can just write that here beside. For perpendicular vectors, A dot B is equal to 0. And at different times you can use that for justification as well. For parallel vectors, if two vectors are parallel, obviously they move in the same direction. Okay? And so the angle between them then is either 0 or 180. So that's why we've shown these two. And then using a cos of 0 obviously is 1. The cos of 180 is negative 1. And so it results in these two properties. And again, what we can say is for parallel vectors, A dot B can equal either plus or minus the absolute value of A times the absolute value of B. We should have the vector notations in here. Okay? All right. Again, just some quick examples if you want in here. If we had, I'll just show one example. If we had the vectors 3, 4, and 4, -3, for example, we can take their dot product. So the dot product would be 3, 4 times 4, -3. All right, and we'd get 12 minus 12 for an answer of 0. Okay. For parallel, if we start with two vectors, for example, let's say we have, again, for them to be parallel, they just have to be scalar multiples of each other. So it's 2, 5, and let's say 4, 10. Okay, like that. And now what we'll use is we'll use one of these properties. So we'll just take the scalar product first. So we'll have 2 times 4 plus 5 times 10. And that should equal the root of 2 squared plus 5 squared times the root of 4 squared plus 10 squared. Okay. The left-hand side is 58, and the right-hand side is the root of 29 times the root of 116, which actually does equal 58 as well. So in the end, we get 58 is equal to 58. So the dot product is equal to the product of the magnitudes. And obviously, if one of the signs was different on one of the vectors, you would get the negative answer. All right. So and that would also be okay. That would also show that they're parallel. All right. Moving along here. Oh, right. The vector equation of a line, and this again it works both in 2D and 3D. All right. This is the form of the vector equation of a line. It's R. It's in vector notation, although they're bolded. Okay, so hopefully that also shows it. So all three of R, A, and B are vectors. T is not a vector. T is a parameter. It's actually a scalar quantity. All right, I'll explain that in a second. First thing though is that R represents the general position vector of any point on the line. So R can be any point on the line, and it's the position vector of any point on the line. The vector A is a given position vector of a point on the line. So it's a particular one. It's one that we know. All right. T, like you say, is the parameter. It represents how many times you move according to the direction vector, which is the vector B. All right. B is a direction vector. It's parallel to the line. And anytime that a question refers to the vector, but the vector is given as a vector equation of a line, it's important to know that B is the vector that's being talked about. So any work you want to do, if you want to find the angle between two vector lines, you would use both of their B's. Both of their B's, very important. Okay. Sometimes R can be represented by, let's put it over here, it can be represented by the column vector x, y, z. And again, it would be in that form because it's a general point, it's an unknown point. It could be x, y, z, or obviously in 2 dimensions, it could be just x, y. Okay, so that's just a representation of R, possible representation. All right. Let's do a couple questions with this. All right, so the first example here is to find the vector equation of a line through this point 1, -1, 3, and parallel to the vector -1, 3, -1. Sorry, the photocopy didn't come up, or the slide didn't come up very well. This is a -1, a negative I, plus 3 minus k. So to answer the question in A, we're going to use this form. R is equal to A plus TB. Again, our answer is going to be R is equal to. Now, For the position vector A, we're going to use a known point, and that's given to us. So it's 1, -1, 3. That's a point that the line passes through. That's a point on the line. And then plus the parameter t times the vector b. And since we're moving parallel to this given vector, that becomes the same as the vector of our line. So -1, 3, -1. And that's the vector equation of the line passing through 1, -1, 3, and parallel to that given vector. In question B, it says find the vector equation of the line through the points A, which is 1, 0, -4. So A, 1, 0, -4, and B, -2, 1, 1. -2, 1, 1. Okay? So if we want to find this vector equation, it's essentially the vector equation of AB. We first need to find vector AB. Okay? So again, this is what we've been doing. So vector AB again is OB minus OA. And OB is -2, 1, 1 minus vector A, which is 1, 0, -4. And that answer is -3, 1, and 5. Like that. So that is the vector of my line. I can now write the vector equation of the line AB. So it will be R is equal to, now since I know 2 points that pass through this line, I can use either of them as my A vector. All right? Doesn't matter which one. I'll just use A though. I'll go 1, 0, -4. It would have been all right to use -2, 1, 1 in that spot. And then minus T times the vector that gives this line direction, which is the -3, 1, 5 vector. So that's the vector equation of the line passing through A and B. In C, now here's what I was talking about before. So to find the acute angle between these two vectors, or between these two lines, I should say, we're actually going to use both of their vector b's, and this is very, very important. This is what you must do. If you choose the wrong vector, you won't get any points in the question. So here we're calculating cos of theta, and I'm going to use, doesn't matter what order I put them in, it's -1, 3, -1 times -3, 1, 5, and then over there, the product of their magnitudes. So this is the root of -1 squared plus 3 squared plus -1 squared, multiplied by -3 squared plus 1 squared plus 5 squared. Okay. On top, when you do the product, you get 3 plus 3, 6 minus 5, so that's 1. And on the bottom, you get root 11 and you get root 35, which is equal to 1 over the root of 385. And when you do the inverse cosine calculation for that, you get theta is equal to, it works out to be 87.1 degrees. All right. So that's how you would do the angle calculation between two vectors. Can't stress enough that you need to use the B vector of both lines. And now to find out if two vectors intersect or not, or where they intersect, if you can understand that, for example, this line here fits the form x, y, z is equal to those, and this one also does. So it's also x, y, z. Now if we're telling you that these two lines intersect, their vector equations must be equal, and this is how you'll set this up. So you'll set the two equations equal to each other in this way, so you'll go 3, 0, -1, plus, I'm going to use the parameter s in here. Usually s and t are what are used. Quite often it might be Greek letters too, lambda or theta, or beta, something like that. Plus s, 1, 1, 1, has to equal, at some point they have to equal the other equation, which is 6, 2, 0, plus t, 0, 4, 8. And now what has to be true is the x's have to equal, the y's have to equal, the z's have to equal. So out of this you can write three equations. So you can write 3 plus s has to equal 6 plus 0t, if you want. You can leave that off. The second one you'd write is s is equal to 2 plus 4t. And the last one, negative 1 plus s is equal to 8t. And again, obviously, we're solving a system of equations, two equations, two unknowns. We only need two equations. Obviously, we have three, so you only have to work with any two of them. Obviously, you can make a good choice. The first equation only has the one variable in it, so right away out of this you get s equals 3. And then from there you can solve for t by substituting into either of the other two equations that you have both s and t in them. So here we could say 3 is equal to 2 plus 4t. 4t equals 1, t equals 1/4. All right. And now, just as a check, just to show you how this worked. So over here we'll say the check. These parameters need to take you to the same point on both lines. So in the first line, our x, y, z point should be at 3, 0, negative 1 plus 3 times the vector 1, 1, 1, because we found the parameter s to be 3. And so now this point leads to 3 plus 3, 6, 0 plus 3, 3, and negative 1 plus 3, which is 2. Do the same thing for the second line. Again, it's going to be x, y, z as well. Again, its first position vector is 6, 2, 0. And now we're going to go plus 1/4 of 0, 4, 8. And now when you add these components up, we have 6 plus 1/4 times 0, that's 6. 2 plus 1/4 times 4, well 2 plus 1, that's 3. And 0 plus 1/4 times 8, which is 2. Obviously both of those points are the same, and that must be then the point of intersection of those two lines. All right, this video's gotten long, so we'll cut her off here.